So this talk came about because me and Paul got talking about like testing APIs in another meetup group. And I was like, everybody does this. Everybody just tests APIs like this. And he was like, no, they don't. And I was like, yeah, they do. So then this kind of spiraled off into this talk. So that's a load of pointless information about me. But if people want to get in contact with me, Twitter's normally the best place. So how do you normally test your APIs was the question, what we kind of stumbled on when we were talking to each other. And these are a few of the kind of ways to test the APIs. And I tweeted it out as well and kind of just trying to get a bigger audience of how people test their APIs. And one of the most common ways was to just throw it at your users and kind of, if it blows up in their face, then go fix it. And this was quite a common kind of pattern what people was doing, which surprised me. They just didn't write any tests, didn't write any unit tests, just threw it out to the production and kind of just expected things to work. And if they didn't, they just rolled it out again. Another way is to kind of do a similar approach and do an A/B testing. So you roll it out to like 50% of the audience or maybe less. Or you could have like a subsection of users, which are your beta users. So you might have some internal staff which use your software and you just roll it out to them first and then roll it out to everybody else once you know it's actually working and isn't broken. And this is another quite common pattern, and we've used this at previous companies what I've been at. Another very common kind of product to use is Postman. And this product has got a nice UI. You can click around in it and send requests off it to your APIs. And that's another way. There's also Swagger Docs. So if you've got Swagger Docs enabled for Asp Net Core, which actually is on by default in developer mode, I think it is. You can just click around here as well and just submit requests really easily to your API and test it manually as well. You can also use Swagger without kind of being automatically generated, and you can use that as well. And that's totally fine. This is a cool tool what I've used quite a lot of times is REST client in VS Code. And it's just pretty much a text file which describes kind of HTTP requests. And what you can do is kind of just send off get, post, deletes to an API, and it gives you the response back. And that's a bit of like an example of that happening there. And I find that's really useful for kind of like just manual testing, to be fair. Another way I've seen used in businesses as well is just scripting it out using either Bash or PowerShell. So one good advantage of using Bash or PowerShell is you can automate on your build as well. And some of these can obviously be plugged into your continuous integration pipeline as well. So Postman, there's a Postman CI, which you can plug in. You can plug in some Bash and PowerShell scripts as well. And that brings me on to my little quiz. So I sent everybody a link in the chat. So if people can start that out, that'd be great. And this isn't going to go over the top of here. So one second. My other windows disappeared. There we go. So if people want to kind of vote of kind of how do you currently test your APIs, that'd be great. And we can get a bit of more kind of understanding of how people currently test them. Cool, so some people are actually using the Asp Net stuff built in. Loads of people using Postman. Postman seems to be the most common one on Twitter, actually, what people were mentioning. Not many people mention Postman with the CI/CD integration. That seemed to be hidden away in their documentation. Cool, I think everybody's voted. And the next question is like, do you test your APIs in a continuous integration suite? So this is like on your build server or on your releases. It's interesting. Nearly 50%. Cool. So let's flip back to my slides. So that brings me to questions like, what do we want from testing? So these are a couple of things what I kind of listed down when I was thinking about this. And the whole point of testing is to bring confidence that our software is going to work in production. And having confidence that it's going to work in production just means like you've got better quality software in general. And that means that people are going to have better satisfaction of using your software. They're not going to have loads of error messages popping up, and it's not going to be doing things where you don't expect it to do. One other thing about testing is you want it to give you fast feedback cycles when you're writing the code in general. So when you're kind of developing the software, you want to be able to prove that you're kind of doing the right thing at the right time when you're writing the software. So you write a test and then you kind of want to make it kind of pass in that perfect way for that one test. It also allows us to document our software features. So our soft test documenting how our code should be used. And also it safeguards us for the future. So once we've kind of written a test, we know that test should work in like 10 years down the line, unless we change actually how that feature is being implemented, or well, implemented actually is used. And kind of, we want to do that in an automated way. So we kind of want to remove the manual testing because things are slow doing things manually. We're going to just do the same thing every single time we test. So we might as well make it automated. And that gives us instant feedback. So if a machine's doing it, it can run it in like less than a minute. And we don't want to kind of have a human kind of involved running it for every hour. It also means we can plug it into our CI/CD pipelines, and we can also run it in the future as well. And what a confidence we want in tests, well, to gather confidence in our tests, we kind of want to avoid kind of mocking at all cost. So the more stuff we mock, the less confidence we have that our tests actually are proving that thing is going to work in production. And it's same goes for kind of, we want to test it how people are using it as well. So the features, what people are using, we want to test the whole stack as a thing and not kind of test parts of it. Which brings me on to the library, which is the integration testing with Asp Net Core. So say we've got like an API, which is our events API, and we've got some methods on here, which are a get method, which we just call a get on the events. We also call post on events, where we can create an event, and we also can get a certain event, and we can also delete an event if we're an administrator. We could kind of create a unit test project in any tool of choice. So you can use a CLI. I'm familiar with like using Rider quite a lot. And then we just go create a normal project. After we've created the project, we need to change the project type to be this Microsoft.NET SDK web. And I always forget to do this, and it comes up with loads of errors, and then you Google it, and then it tells you to change this. And then you need this NuGet package here, which is the Microsoft Asp Net Core MVC testing library. And that gives us two real objects what we're going to be using. One is this test server. And this has been around for quite a while, I think a lot longer than this web application factory. And this is to kind of host our Asp Net Core application inside of a test harness. So instead of using something like Kestrel to host the API or the ISS integration, we use this test server to kind of host it. And then this web application factory creates these test servers and also gives us a HP client to kind of integrate with it. So this is kind of what it looks like if you just use the test server. So we go off and we call the create host builder, which has been now using our program CS application. We tell it to go build it. We give it to the test server with all the services. We then tell it to start. We then create a HP client with the handler inside it, which is created from the test server. And then we can use this HP client like any other kind of HP client. So we just call our API like we normally do if we're integrating with a third party. And then we can get back the response code from our response and then check that it's 200 OK. And then finally, we can stop the process. But if we're using the web application factory instead, all we do is we tell it to new open web application factory with our startup CS. So this is where we configure our actual application. And then we can go to it and say, go create me a client. And that will give us a HP client back straight away, which you can use to kind of talk to the our API. So this means we can write like these XUnit tests. So this, for example, is creating a web application factory we're creating a HTTP client from that factory, and then we're going to that HTTP client, we're doing a GET request to the /events endpoint, and we're just checking that status is okay. It's really simple. Alternative, we can use the post endpoint, exactly the same. So this is as if we were just integrating with like a third-party API. So I set up my kind of data for my test, which is my expected event, which I've got an ID, name, and start date. This is using an anonymous object, but you can just use a typed object if you want. I usually set up like the Json payload myself. And this is because I want to separate the models for the implementation detail from the actual test itself. So I can ensure that this is going to work with this expected JSON from the outside world. So I just pass that into a string content and tell it it's going to be an application JSON payload. And then we tell it to post it to the events endpoint with that content. We can make it sure it's a successful status code. So this is a 200 status code. And then we can go fetch all the events back from using a GET request again. And this time I'm just getting them all back as typed objects using deserialization. And then we can just check that all them events are equivalent to the actual expected events. And that'll pass. But sometimes we want to kind of modify this web application factory. So a lot of applications are always vastly different. So there might be kind of security concerns where you have to add in different authentication for it. You might want to swap out different kind of layers. Maybe you don't want to kind of use to connect to a real SQL Server instance. You want to use the in-memory one, which I kind of don't advise in the first place because it works a bit differently. But we kind of might want to kind of reconfigure some services. We also might want to swap out some configuration. Maybe we're using feature toggles for certain things where we need to change. And when we run it by default, we want all these feature toggles turned on. You can also replace services as well. So instead of reconfiguring, you can replace the whole service. And also the authentication pipeline is also customizable. So we do this by just inheriting from the web application factory. So this is the one that we're creating every single time. And now I've created this demo web application factory which inherits from that. And from inheriting from it, we can override different methods. And one of them is actually a configure web host. So every time we configure the web host, we can do different things on this builder. So we can set the environment. So we can say this is the automated test environment now. So different, like with Asp Net Core, we change the environment, and within our configuration, when we wire things up, we wire the pipeline differently, and we can change the environment to make it so the pipeline gets wired up differently. And this also is calling the configure app configuration. And this is just plumbing in a new in-memory collection with some extra data. So I've got this connection string here, and then I've got another random key here. We can also override reconfigure the services by calling configure services. And if we want to replace services, we can call configure test services. And this just replace like our events data store with a mock data store. There's other methods what you can override. One of them is configure client, which is actually just reconfiguring the HTTP client. So maybe you've got a bunch of HTTP headers which always have to be there. So we can append some default request headers like X demo header, and we can put a variable for that kind of header. There's a bunch of other kind of methods you can override, but they're usually the ones what you use. So you can do things when you're creating a server, you can reconfigure the server. You can also attach to the actual services as well and kind of make that return back different things. So it's all pretty configurable. So we create a web application factory for our given application. So it looks the same and works the same for all of our tests in the way that application expects. But for a single test, we might want to swap out different things as well. So maybe we've got some feature flags where we want to turn a certain feature on to test a single functionality. So we might want to swap out different configurations for that. And we also might re-customize the authentication pipeline as well. So if you're thinking about, we've got a delete endpoint and we want only administrators to kind of be able to delete events, we might want to write a test where we kind of elevate their privileges with our customer authentication pipeline. And then we test that one scenario for that delete. But everything else, we should always have unauthorized when we kind of hit that endpoint. Also, we might want to reconfigure services and replace services as well. But this is, I've never kind of used these ones. I've always kind of used these two when customizing single tests. So this is an example of that. So this is the post endpoint where we're posting some data. We've got a extra bit of configuration. So we go to configuration, stuff in .NET, check if this flag's been set, and if it's true, then we test the name and say bad request if the name isn't starting with the example. And for that, we use this thing called with web host builder. And this is similar to the other one where we override it, but this is just in line in the tests. And we can say, go use the setting of validate name feature and just set that to true. And now this web application, what's been created, what we're communicating to with the HP client will actually respond in the right way to do that. And so now when we send something which hasn't got example as the first line in the name, we get a 400 bar request in. Another one is to reconfigure the authentication pipeline, as said. So this one just authorizes this delete endpoint with administrator roles. We can plumb in some extra authentication into the pipeline. So this is using this test auth handler. And then this test auth handler just adds an extra custom role into our claims. And then when this runs, it'll just be the right kind of type. And I don't know if I'm running like a bit too over, but I'll show you a short example of this. So this is a example events controller. So we have this get endpoint where we can get all the events from the store, and our tests are over here. And this is just new up some extra kind of the web application host factory, HP client. And then with this HP client, we can just do what we said. We can just do the get async. You can pass in the URL, and this could be anything. So that's how simple the tests are to write. Let's do 3 lines to just check the status code when you hit that endpoint 200. We can run that in our tests, and then that'll just pass perfectly fine. So that's pretty much how easy these are to write. And it's literally just as if you're integrating with your API from externally, but these are a lot faster to run because they're using it in memory test server. So that just brings me on to my final slide, which is some bonus test points for testing bonus points. So I'd avoid sharing models for serialization. So keep your kind of models in your tests completely separate from your implementation models for the actual deserialization and serialization. And I always try to just write them as blobs of like strings, really, because then you can prove that the incoming data or external data going out is actually as you expect it is going to be. Or avoid the mocking services. So don't use things like the memory entity framework. It works completely different to what you expect. So the current company, what I'm working at, we use the memory entity framework stuff. We wrote loads of tests against it. And then when we actually released it, it just blew up all over the place because of like foreign keys and all sorts of other random stuff. And also some queries worked in the memory entity framework, like didn't work in something else. So we just spin up like SQL Server in a Docker container now. So I'd advise to do that instead. So I just try to kind of avoid kind of mocking as much stuff as possible and just use the real implementation of things. But that's it. So I'll answer questions later on because I think we're running over a bit.